Okay, in this video we will be talking about the event versus probability. We have to understand the difference between the two things. Also, we will be discussing three different probabilities, types, let's say types of probabilities, or different assessments, actually, probability assessments. So first of all, let's have an example about rolling a die. So if I ask you to roll a die, so rolling a die only once now, right? So what is your sample space? The sample space is either you are going to, in one experiment, either you're going to get 1 heads up, or 2, or 3, or 4, or 5, or 6. You will never get 7 because there's no 7. You have 6-sided die, fair die. If you roll the die, you are going to get one out of these outcomes. Now, let's define an event. Let's call it E1. What is E1? Suppose you are interested, you want to know the events of getting the event of getting an odd number. What is this event? What are the elements in this event? So the question is going to be, what are the elements of this event? So this event, E1, will contain these elements only, 1, 3, 5. Let's define another event. Suppose that you care about that event, let's call it E2, the event of getting a number less than 3. The event of getting a number less than 3, that means you are going to get one out of these numbers. Either you're going to get 1 or you're going to get 2, right? Again, the first event we defined, we care about. This is the thing that we are interested in. The event of getting an odd number. What is the event of getting an odd number? If you throw or roll the die, you're going to get either 1 or 3 or 5 as an odd numbers. The second event we defined is the event of getting a number less than 3. What is that? What is the event? I did not ask what is the chance. I did not ask what is the probability. We are just asking about what is the event. Now, these are the events. Now, if I ask you, what is the probability? What is the probability of getting, let's say, an odd number? The probability of getting an odd number. This type of probability, we call it classical probability, because we're going to talk about this. Because every event can, all event has an equally likely, or they have equally likely outcomes. Basically, they have the same chance to occur because it's a fair die. When you roll it, there's nothing is going to impact where the die is going to land. So all the numbers, they're going to have equally likely outcomes. So if I ask you, what is the chance that you're going to get an odd number, without doing any math here, without doing any statistics or something, if I ask you what is the probability, what is the chance, what is the probability, what is the probability of getting an odd number? What is the probability of getting an odd number? Remember, we said something about the probability. We said the probability is a number between 0 and 1. Maybe you're going to use the word chance. What is the chance of getting an odd number when you roll the die? If you look at, use your intuition and look at the numbers. We have 6 numbers. One of them can occur. They have equally likely occurrence chances. So what is the chance of getting an odd number? You can tell me, oh, half of these numbers are odd, basically. So the probability of getting an odd number when you roll the die is going to be 50%, correct? 50%. 50% means what, basically? Because you have 3 numbers odd over the total number is 6, so you're going to get 50%. So basically, we write this: the probability of event 1 equals. Now we speak probabilities now. The P of E1, the probability that getting an odd number, which is E1 in this case, is we have 3 odd numbers over the 6, the total numbers, which is 50%. Now, without doing the math now, just look at the numbers and you tell me, oh, it's 50%. The chance of getting an odd number because you have 3 out of 6. Right? And the same thing occurs here. If I ask you what is the probability of this event, or the probability of event 2, you can tell me, okay, we have 2 out of 6, basically, which is third. So the chance of getting 1 or 2 is going to be a third, right? So it can be third, or approximately 33%, right? So this is the difference between the event and the probability, and we have to recognize that we are always finding the probability of event or events. Okay, so before you find the probability, any probability, you have to define your event or events. You have to know them first. Okay, now let's try now to talk about probabilities in the following few slides. We have three methods of assigning probabilities. The first one is the very common one, which is the classical probability assessment. This classical probability assessment, it's based on the ratio of the number of ways an outcome of event of interest can occur to the number of ways any outcome or event can occur. And these individual outcomes are what? Equally likely. Like flipping a coin. We have an equally likely, both of them, head or tail, they have equally likely outcome. Because the coin is, we assume that it's fair, so each outcome is equally likely. They have the same chances to occur, right? So what we do, we just divide number of ways of EI can occur over the total number of possible outcomes. In our previous example, what are these sample space total possible outcomes, SS? How many elements do we have? 6. So now we have 6. And what is the number of E1? If I write this in terms of E1, probability of E1 equals the number of ways E1 occur divided by the total number of possible outcomes, or basically let's call it sample space, SS. So in the previous example, number of ways E1 occur, we have only 3 elements. It could occur, we can get 1 or 3 or 5, so 3 over 6, because you have 6 elements here, so which is half, 50%. So this is a classical probability assessment. Let's have an example. The manager at King's Fine Clothes planned to hold a special promotion over Labor Day weekend. Each customer who make a purchase exceeding $100 will qualify to select an unmarked envelope from a large drum. This is important. Why important? We can speak about this. Inside the envelope are coupons of percentage discounts off the purchase total. At the beginning of the weekend, there were 500 coupons, right? So what is the type of the probability here we're going to use? We are going to use the classical assessment, classical probability assessment. Why is that? Because these envelopes are unmarked, right? And they are, from outside, and they are thoroughly mixed in a drum. So any one envelope has the same probability of being selected as any other envelope. So the outcomes are what? Equally likely. So we don't distinguish any of these envelopes. So everyone has the same chance to be chosen, right? So the total we have 500. So what is the probability that the first customer will receive a 20% discount? The probability of the first customer is going to get 20% discount. You can call this the event 1. You can call it this one E1. You can call it P of E1. P of E1, okay, how many coupons contains 20%? We have 50 coupons. We have 50 chances over what? The total, which is 500. Right? In this case, you just divide them, you get 0.1. Probability is less than 1 greater than 0. If the first customer received 20% discount, what is the probability that the second customer will receive 20% discount? So this is another thing that we have to think about. Because now the first customer already received 20% discount, so we have 1 coupon taken already. So what is the chance that the second one is going to receive, let's call this one PE2, or PE2 given PE1, given, let's call this one, let's leave this jargon to the next video. So what is the P of the second, let's say second customer will receive 20%. We need to find the probability of this. Actually, how many coupons left? 49. What is the total? 499. Okay. What is the probability that the first customer receives 30% discount is another event, which is 30% discount. How many? We have 45 out of 500. If I start from scratch, there's not A, B, C, D, by the way. Okay. Given that the first 2 customers received 10% discount, what is the probability that the third customer will receive 5% discount? 5% discount, we have 5 coupons, but the total number is different now. So 5% discount is going to be 5 over, we have 2 coupons already taken, so we have 498, right? The second type of assessments, we call it relative frequency assessment. This assessment is the probability as the number of times an event occurs divided by the total number of times an experiment is performed in a large number of trials. So we have many numbers of trials. Technically, the relative one, it's based on experiments or based on historical data. You just count number of times the event interest occur, you count them, then you count number of trials. Example. We have census of 2,500 employees, mid-sized company, retirement account. These are the retirement accounts. The account balance is less than 25%. We have 635 males, 495 female. The account balance is between 25 to 50. About 50 is this, and so on. So these are kind of data that we do have right now. So based on the relative frequency assessment, what is the probability that randomly selected employee, this is my event, will be a female? Again, you can say E1, okay, you have to define again. To find the probability, you have first to know the event. A randomly selected employee is a female. I don't know why is that bad. Employee is a female. This is your event. Now to find the probability, you can tell me the probability of being a female is number of females. Number of females. What is the number of females? You just add all of the females. The total of the column, which is actually, if you add them, you get 1,000, and here we have 10. 1,010. So it's 1,010 number of the females divided by the total number of employees, which is 2,500, because I'm going to pick one female out of the total number of employees. How many females do we have? 10. Over the total number of employees, let's just do the calculations quickly. We get here is about 0.44. Based on the relative frequency assessment, what is the probability that a randomly selected employee will have an account balance between this? This is my E2. This is my other event. This is E2 again. This is E2. The goal is to find the probability of E2. This is important. So we need to know how many people have this kind of account. So we are looking for these people. 180 plus 210. So we have 185 plus 210. They have this account divided by 2500, the total number, right? Divided by the total number. So which is 395 divided by 2500. What we get about 15%, right? Compute the probability that a randomly selected employee will be a female. A female. This is my event. Will be a female with an account balance between. So this is, we call it. This has a name. We're going to talk about this one. What is the chance that you're going to pick a female with this balance? Let's look at these guys. I mean, these people. A female with this account balance. Where is she or they? We have these guys. There's a group. There's a group highlighted in yellow. These are the females with this account. So this, let's call this one E3, by the way. Oops, E3. What is E3? Randomly selected employee is a female, has an account between 50,000 to 100,000. So we need to find the probability of E3. So we need to count how many of these guys do we have. We have 260 divided by the total number. Right? Let's divide them. We get 10, 40. So these are the types of, the first two types of probability assessment. The last one is the subjective one. This one depends on the state of mind. Based on their experience, they can say, oh, we're going to make a profit of this. We're going to make sales, like 20% increase in sales. So these are the chances that people, it's subjective. So long-time friends, Pat and Tom, agrees on many things, but not the outcome of the American League pennant race and the World Series. Pat is from Boston and Tom is from New York. They have steak dinner bet on next day's race, with Pat betting on the Red Sox and Tom on the Yankees. Both are convinced they will win. What is the probability assessment technique? Subjective. Why subjective? Because state of mind. Their experience, they believe, right? It's subjective. So if you look at these examples now, so it says in the following scenarios, what is the probability of assessment that would most likely be used? What is the probability that a major earthquake will occur in California in the next 3 years? This is kind of, I believe this is subjective because we don't know, it depends on people's experience or state of mind. So this is subjective, I would say. What is the probability that a customer will return a purchase for a refund? Maybe this is going to be dependent on historical data. So this is going to be, when we talk about historical data, we talk about the second type, which is the relative. An inventory of appliances contains 4 white washers and 1 black washer. If a customer selects one at random, what is the probability that the black washer will be selected? So we're talking about the equally likely outcomes, because they have, the washers have equally likely outcome or chances to be selected. So this is classical. The next video we are going to discuss probability rules.